All right, guys, so as you saw in my email, and hopefully by now you've gotten an email from College Board, they said that they're going to change the AP test. They're going to take out applications of integration, which we were currently in. Differential equations is the last topic that they're including in the test that we haven't covered, so that's why I'm stopping with area between curves and going into differential equations and the last topics that you need to know for the test. Then we're going to review and hopefully be prepared for that test. And then after the test, I'll finish up with the applications of integration because they are really important for you to know. All right, so differential equations I just highlighted here. Differential equations are equations involving derivatives. They're going to give you the derivative. When I say solve a differential equation, I'm asking you to find the original equation where that derivative came from. So you know already, if I'm at the derivative on that function q, I'm here, I'm at f prime. And if I want to go up, I need to integrate. All right, this is nothing new. I need to integrate. So we know we need to do this. But this is our problem right here. We cannot integrate with multiple variables. You can only work with one variable at a time. So this is what we talk about. We need to separate the variables. So you're going to see your worksheet for tonight is going to be separation of variables in order to solve differential equations. Our very first step here when solving differential equations is to separate the variables. One side can contain x and the other side can contain y. The only way to separate is through multiplication or division. There's no such thing as subtracting an x over or adding a y over so that you can separate those variables. So here, what's going to drive this is the dy and the dx. That's what you want to concentrate first. dy and dx need to be separated. So right here, they're together. In order to separate that, I'm going to multiply this side by dx, and therefore this crosses out. And I'm left with dy on this side and 2x dx. So the dy and the dx is going to decide which side's going to contain the variable. Wherever dx lands is where all my x variables can be, and wherever dy lands is where all my y variables can be. There's no other y variable here that I need to move over, but if there was, all the y's would have to be on this side. Now that I look at this equation, I go, all right, I have them separated. I now can integrate. So here, the variable of integration, it's basically like two integration problems. Here, the variable of integration is y, and the number here is 1. We know that to integrate, we add the exponent. Well, right now, the exponent here is y to the 0 power. If I add 1 and divide by that new exponent, again, y to the first power, and the dy turns into my plus c. That should hopefully ring a bell. Here, when I go to integrate this, it's already to the power of 1. I add 1, so I get 2x squared divided by 2, and this dx turns into c. So when I clean this up, I get y plus c is equal to x squared plus c. Now, I want to get the c's to one side, so I'm going to minus the c over. But remember, that does not cancel the c on this side. All right, that just becomes another c. So I end up getting that y, my equation, y is equal to x squared plus c. This is what we call our general solution to a differential equation. That wasn't so bad. I'm going to warn you, the next question's a little bit more difficult. I should say a lot more difficult. So here we go. We're given this equation. How do I know I'm dealing with a differential equation? I see dy dx there, okay? If they said solve this differential equation, that means that they want me to get to a point where I have y equals as my solution. So here, I'm looking at this and I'm seeing that there's a major problem. If I go to integrate right here, I can't do that. On this side, I have two variables mixed together that aren't the same, and here I have two variables mixed together that aren't the same. So what I need to address first is the dy and the dx. I need to separate that first. So I multiply this side by dx, multiply this side by dx, and now I'm left with x squared plus 4 those dx's cancel. I get dy equals xy dx. So I'm here. This is telling me that on the left-hand side can only be the y variables, and on the right-hand side can only be the x variables. So it's up to me to move those variables to the correct side. This y needs to move. So I'm going to multiply this side by 1 over y and this side by 1 over y. And that takes care of that. And so on this side, I'm left with x dx, and I'm happy with what that looks like. And on this side, I'm on my way. I have 1 over y times x squared plus 4 dy. But the dy tells me only y can be on that side. So if only y needs to be on that side, I need to get rid of this binomial. And I can do that by dividing that over. So I divide that by x squared plus 4, and I divide this side, x squared plus 4. And now I have this gone, and I have 1 over y dy is equal to x over x squared plus 4 dx. And now I'm happy. What I just did was I separated those variables. That's our very first step to solving differential equations. Separate the variables. Okay, so we're here. Now that we're here, I'm ready to integrate, except it's not in its correct form for me to integrate. Remember, there's only U substitution or basic integration. There's no such thing as a quotient rule or a product rule and so on. So I need to move this to y to the negative 1 dy is equal to x squared plus 4 to the negative 1 dx. Now I can integrate this, but when I see this, I'm reminded that if I go to add 1, I get a 0, and divide by 0, can't divide by 0. This is my ln problem. Do we remember that? You don't have to use U substitution for ln unless your base is more than a monomial. This is just a monomial, so when I integrate this side, this is just ln of y, and the dy turns into plus c. However, on this side, not so easy. If you look at my base, it's not a monomial, so I want to use U substitution to get that integrand in the correct form before I integrate. So I just integrated the left side, but I can't integrate the right side yet. I'm going to use U substitution. So off to the side, U is equal to x squared plus 4. If I have a U up, I need a du, and that becomes 2x dx. We solve for the dx, and dx is equal to du divided by 2x. So we sub in. The x stays. This turns into u to the negative 1. Dx is du over 2x, and I see that my x's cancel. And by the constant multiple rule, I'm going to pull out a 1/2. So on this side, I get 1/2, and I get u to the negative 1 du. And on this side, remember, I'm just bringing this down. I'm not paying attention to that side I've already integrated. But this integrand is now ready for me to integrate, and it just becomes ln of u plus c. And I have ln of y plus c. My last step is to put in my u, and I get 1/2 ln of x squared plus 4 plus c. So far, hopefully we're on the same track together. Moving on. So now we're here. So just like before, I'm not done solving this differential equation until I have y equals. And I see that's going to be a little bit more difficult here because y is in the absolute value and it's part of an integrand. So for me to get to y, I need to get this out of log form. So just before I start doing that, I'm just going to minus the c over, and by now you should feel comfortable knowing that that does not cancel the c on the right-hand side. It just becomes a different constant. So now I'm here. And then I say, all right, I would like to get y by itself. I need to change this into exponential form. The base is e. Remember, a log equals an exponent. So this whole thing is an exponent. And so I can rewrite this as the absolute value of y is equal to e raised to the 1/2 ln of x squared plus 4 plus c. And this is where it gets a little tricky. I go, oh, e to the ln, and there's that e. I almost want that box, but that 1/2's in front. So that 1/2's going to go right here, and I'm going to rewrite this as the absolute value of e to the ln of e, absolute value, x squared plus 4 to the 1/2 plus c. And then here, whenever I have an exponent that's been added, what really had happened, can you hold that? Thank you. What really has happened is that we multiplied. So this is the same thing as ln of x squared plus 4 to the 1/2 times e to the c. Now, e to the c is just another constant. Think about it. 2.71 raised to some power is just a constant. So I'm going to rewrite this as just the c, and I'm going to use it as a coefficient because it's being multiplied. So now this becomes absolute value of c e ln, there's that small e, of the absolute value of x squared plus 4 raised to the 1/2. Okay, now I'm going to apply the fact that here's my box rule. Remember, it's not the best box. So this comes down. So now I have this. I have the absolute value of c. This comes down as the absolute value of x squared plus 4 to the 1/2. And you know anything raised to the 1/2 is the square root. Now the absolute value, that's fine because we can't take the square root of a negative, so we can just drop that absolute value and just assume that to be positive. And I'm almost done. Y is almost by itself. Now absolute value means that anything in here could be a positive form of the answer or a negative. So y is equal to plus or minus c square root of x squared plus 4. Oof. And that's my final answer. I know that was a lot. So what I want you to do is try that same idea. And I'm sure many of you will have to watch this video at least 2 to 3 times to understand exactly every step that we did. So please be prepared to do that. And when you're done, I want you to try solving this last problem. Whoops, I didn't put the actual problem down. So you're going to solve the following differential equation, y equals 0 equals 1. Look online. I'm just going to take 2 pictures, one with the solution and one with the problem. Please try it, and we'll talk after.